everyone. So now we're going to be talking about how to write exponential equations. We just talked about how to graph them. And if you don't have a graph or if you can't see it on a graph, this is the other way we can do it. So as you know, the general form for an exponential equation is y is equal to a times b to the power of x. And we've kind of talked about it in the last video, but a is like your starting point or your y-intercept, and then b is how fast it's growing. So we're just going to jump into these examples so I can show you. We're going to really use this equation y is equal to ab to the power of x. When you have a table, like in the first two examples, you don't need all of the information. You really only need the first 2 points. So I'm just going to write the first 2 points out here. So it would be 0, 100 and 1, 20. So what we're going to do is I'm going to start with that equation. Y is equal to a times b to the power of x. But I'm going to take my first point, which is 0, 100, and replace the x and y with those numbers. So I know that this is x and this is y, which means that I'm going to rewrite this equation as 100 instead of y is equal to a times b, because I still don't know what those two things are, to the power of 0, because my x is 0. Now, if you remember from rules of exponents, anything to the power of 0 is 1, or it cancels out, which means that automatically I know that 100 is equal to a, because that b to the power of 0 got canceled out. Great, so now we have one of my numbers, because we're looking for a and b. Once we find a and b, then we know the equation and we're done. So I already know one of my answers, so I'm going to rewrite my equation and replace the a with what I know it is, which is 100. So I'm going to say y is equal to 100b to the power of x. Now that I have that, I'm going to plug in my second point for x and y. So I'm going to say, instead of y, I'm going to put 20, because that's my y for the second point, is equal to 100 times b, because I still don't know that, to the power of 1. All right, so I want to solve this for b, which means I need to get b by itself. To get b by itself, I'm going to divide each side by 100, and I get 20 divided by 100 is 1/5, is equal to b to the power of 1. Now, b to the power of 1 is actually just b, because anything to the power of 1 is just itself, which means that I know that 1/5 is equal to b. Oh, sorry, that does not look like a b. All right, so now I know what a is and I know what b is, which means I should be able to write my answer. So I'm going to say y is equal to a, which is 100, times b, which is equal to 1/5, to the power of x. And recognize that we only replaced the a and the b. We didn't have to replace the y and the x, because that's like y's and x's usually are a part of an equation. And so this is my final answer. Y is equal to 100 times 1/5 to the power of x. All right, let's try that again. So in the second example, again, it's just a table. We don't need all of this information. We're just going to use the 2 first points. So I'm going to have 0, 3 and 1, 18. And once again, we know that that's like the first number is x and the second number is y. So I'm going to start with my general form of an exponential equation, which is y is equal to a times b to the power of x. But now I'm going to replace the x and the y with my first point, which is 0, 3. So I'm going to have 3 is equal to a times b to the power of 0. Once again, you have something to the power of 0, which just cancels out, which means that I know that 3 is equal to a. Great. So now I'm going to rewrite the equation, but with a as 3. So I can say y is equal to 3 times b to the power of x. Then we're going to use the second point, the 1, 18, and replace the x and y again. So I'm going to have 18 is equal to 3 times b to the power of 1. All right, so now we want to solve for b, so we're going to divide each side by 3 to get rid of the 3. 3's canceled out over here, and I end up with 18 divided by 3 is 6, is equal to b to the power of 1. We know that anything to the power of 1 is itself, so I know that 6 is equal to b. All right, now we have a and b, which means we should be able to write our equation. We're going to have y is equal to a, which is 3, times b, which is 6, to the power of x. And this is my final answer. All right. So those are pretty easy. And the reason why they're pretty easy is because you always start with a point with a 0, with your x being 0, which automatically gives you a really easy route to find the other point, or to find your a and then to find your b. when sometimes you don't end up with something with a 0, like in this third example, and so I'm going to show you how to do that. We're still going to do it the same way, but it just gets a little bit more complicated. So I'm going to start with my general form, y is equal to a times b to the power of x, and then we're going to replace it with the first point, which is 4 comma 2 this time. So I'm going to say 2 is equal to a times b to the power of 4. Now, unfortunately, because it's not b to the power of 0, I can't just cancel out the b. So instead, what I'm going to do, I'm still going to solve for a, but to solve for a, I'm going to divide each side by b to the power of 4, which gives me that a is equal to 2 divided by b to the power of 4. Now, that doesn't necessarily help us too much, but I promise it'll help us in the end. So I'm going to rewrite the equation, but instead of saying a, I'm going to say 2 divided by b to the 4th, because that's what I just decided the a was. And then times b to the x. Now, like in what we did for the table examples, we're going to replace the x and the y with the second point, which is 6 comma 8. So I'm going to have 8 is equal to 2 over b to the 4th times b to the 6th. All right, so there's a lot of stuff going on here. Let me show you how to simplify this. So I can rewrite this as 8 is equal to 2b to the 6th over b to the 4th. And based on rules of exponents, because you have a b to the 6th, b to the 4th, you have b's on both top and bottom, we can actually subtract the exponents. So if I do 6 from the top minus 4 from the bottom, I get 2, which means I can rewrite this whole thing as 8 is equal to 2b to the power of 2. Because again, the 6 can subtract the 4 to simplify and get only one exponent. All right, so now we can, it looks a little bit easier. We can now divide each side by 2. And we end up with 4 is equal to b squared. We still need to solve for b, and it's not b to the power of 1 right now anymore, so I can't just say, oh, well, then b is 4. But to get rid of the squared, I would square root. So I'm going to square root each side, and I get, the square root of 4 is 2, so 2 is equal to b. All right, now we know that 2 is equal to b. That's great. But if you remember, we didn't actually figure out what a was. We know that a is 2 over b to the power of 4. So now I'm going to go back to that and replace my b with 2, which gives me that a is equal to 2 over 2 to the power of 4, which 2 to the power of 4 is 16, so I'd get 2 over 16, which is the same thing as 1 over 8. So I know a is equal to 1/8. So my final overall answer would be y is equal to my a, which we just decided was 1/8, times my b, which is 2, to the power of x. All right, last example. And this is really similar because you don't have something with a 0 as an x, but we're going to do it the same way. So I'm going to start with the standard form of an exponential equation, y is equal to a times b to the power of x. Then we're going to replace the x and the y with the first point. So I'm going to have 90 is equal to a times b to the power of -1. Again, I can't solve that for a and just cancel out the b, so I'm going to divide each side by b to the power of -1. And I end up with a is equal to 90 over b to the power of -1, which is what we're going to, now we're going to go back and replace the a in my original equation with that. So we have y is equal to 90 over b to the power of -1 times b to the power of x. Then we're going to go to the second point, which is 1 comma 10, and replace the x and y. So we get 10 is equal to 90 over b to the power of -1 times b to the 1. And then, so we can rewrite that as 10 is equal to 90 b to the first over b to the -1. There's a rule in exponents that says that we really don't like negative exponents. And so to get rid of the negative exponent, we have to shove it either to the top or the bottom, basically the opposite side of the fraction. And what happens is it turns positive. So I can rewrite this as 10 is equal to 90 b to the power of 1, which was already on the top, times b to the power of 1 from the bottom, because I'm taking that b to the power of -1 and pulling it up. Because I'm pulling it up and switching sides on the fraction, then the -1 turns positive, which means I can actually simplify these b to the power of 1s, and I get 10 is equal to 90 times b to the power of 2. because when you're multiplying exponents, you can just add, when you're multiplying numbers with exponents, you can just add the exponents. Okay, so now we still want to solve for b. So I'm going to divide each side by 90. 10 divided by 90 is 1/9, so I get 1/9 is equal to b squared. And then to get rid of the squared, we square root. So I get 1/3, because the square root of 1/9 is 1/3, is equal to b. All right, sweet. So now we know what b is, and we just have to figure out what a is, because if you remember, we didn't actually figure out what a is. We just know that a has something to do with b to the power of -1. So I'm going to replace the b with 1/3. So I'm going to have a is equal to 90 over 1/3 to the power of -1, which, remember, exponents is the same thing as saying 90 times 1/3, which gives me 30. So we know that a is 30, which means my overall final equation would be y is equal to 30 times 1/3 to the power of x. And there we have it. This is how we write exponential equations.